Cool. Well, I guess good afternoon, everyone. I can't really see you. The lights are really bright. So I want to start with a story. All the way from World War II, when the Allied forces were trying to figure out a way to maximize the survival rate for the bombers, because those things were really, really damn expensive. So what they did was they brought in this guy called Abraham Ward and his Statistical Research Group, or SRG, to help them figure out where do they put reinforced armor on those planes. So they started by analyzing the patterns of bullet holes on those planes that made it back into the airbase. And the other researchers suggested that we should put more protective armors around the areas on a plane where they've sustained the most damage, which I think intuitively makes sense. But then Abraham made the observation that the planes that actually got shot down, they were missing from the analysis. And that the bullet holes you find on the planes that made it back home are the ones that the bomber was able to sustain while still safely return back to the base. So in fact, it's the places where you don't see bullet holes are where the planes that got shot down actually has been hit. So that's where you should put the armors, the reinforcement armors on the planes going forward so that you can have more planes coming back home. And the reason why I'm telling you this story is that I personally experienced this survivor bias in how we monitor and alert for our applications, not just serverless applications, but just applications in general, whereby we'd only focus on the failure modes that we were able to identify through experience and through previous investigations and post-mortems, and that the bullet holes that shot us down and we couldn't identify the cause, they still remain invisible to us and will continue to shoot us down in the future. So perhaps instead of trying to monitor and alert on everything that we know about, and maybe we should instead reinforce our metaphorical planes with a stronger armor so that we can offer stronger protection in the areas where we can't easily monitor. And that is where I think observability comes in. So I think it's worth taking a few moments to define what I actually mean by that, because I think when you speak to different people, observability means different things to different people. And when I think about monitoring, I think of it as a watchtower where you can watch out for those known failure modes in the system, the kind of things that are typically, network spikes and CPU spikes and memory usage and so on, the kind of thing that fits really well onto a dashboard. Whereas observability is probably closer to the kind of things that government agencies are doing, but not telling us. Instead, they're collecting vast amounts of data so that they can gain insights into what's happening by only observing it from the outside, which incidentally is how control theory defines observability, being a measure of how well the internal state of a system can be inferred from knowledge of only its external output. So any given system, you have a finite and often small set of known successful outputs for any given input. It could be a 200 HTTP response for a HTTP request, or it could be a row being added to a database, or maybe it's a message for a messaging-based system. It's for every message that comes in, we send out some message to some external system, and so on. And there's also a set of known errors that we know about ahead of time, things like 400 or 500 HTTP response codes. And these sort of things are really easy to monitor and alert on because, again, we know about them. But then there's also a whole class of errors that we know is going to be bad for us, but we don't really know how it's going to manifest in themselves in our system, in terms of how our system is going to behave. And this sort of thing, for example, if a network partition happens in DynamoDB, we know it will be bad, but we don't really know how it's going to manifest in terms of how our systems behave under those failure modes. Because DynamoDB is eventually consistent, so we can probably assume that reads and writes will continue to be available, but maybe when you try to do a consistent read, that's when you're going to get unavailable reads instead. So how do you monitor and alert on those things on systems that we don't own, things like the services that Amazon and other cloud providers provide? But what scares me even more is this whole other class of problems that we don't even know to ask because we don't know what we don't know. And those are the sort of invisible bullet holes that we need to have better protection from. And so I think for that, maybe there's an argument so that we shouldn't just monitor and alert on the things that we know about, or at least not all by itself. Given that there's an infinite number of possible errors, many of which we don't know to ask, Instead, maybe we should consider monitoring and alerting on the absence of the success cases because, again, there's a small and finite set of them. So it's quite easy to monitor those things. For example, it could be HTTP requests that didn't result in a 200 response, or for messaging system where there's some discrepancy between the rate of messages coming in to the rate of message being processed or rate of messages that are going out of the system. So when you monitor on the absence of success, it can tell you that something is wrong, but not what is wrong. And remember, because there's all these unknowns, there's no way for us to be certain anyway that we can use the monitoring system to figure out what has actually gone wrong. And that's where we need to have better tools to be able to debug our system by only observing it from the outside. In terms of the actual implementation of how you do that, I think the general consensus is that you need to have monitoring, log aggregation, analysis, as well as alerting and tracing in your system in order to be able to have the basic ability to debug a system by only observing from the outside without having to attach a debugger to a system that's running in production somehow. And as we build systems that are more and more complex, we're going to need to have more help in terms of figuring out what actually went wrong once our alerting system tells us that something's gone wrong. And in response to us building more and more complex systems, more and more tools becomes available as well in both the open source space as well as in the commercial space. And I think in general, while you find that in the microservices world, especially for systems that are running in containers and on VMs, the tooling is actually pretty good, and it's getting better all the time. But then, of course, Amazon threw a curveball back in 2014 and announced this thing called Lambda, and then that became the arrow to the Achilles heel for all these different tools, because all these tools, by large, they require some form of agent or daemon to be installed on a server somewhere for them to work as intended. And with Lambda, or with other functions as a service platforms, there's just no way for you to install those agents and daemons. So my name is Yan Cui. I'm a principal engineer at a company called The Zone. We just opened up office in Amsterdam, in addition to London and a few other locations. So we offer an affordable and subscription-based platform for you to watch sports, both live as well as on demand. We offer a whole number of different sports as well as different leagues around the world. And we just got the right to stream Italian Serie A and Serie B matches live in Italy, so we just opened up in Italy, and we are available on more than 30 different platforms. At peak, we have over 500,000 concurrent viewers on our platform, and we're coming to the US pretty soon with offers of live matches of boxing matches on our platform. So if you want to find out a bit more about what it is we do and our positions that we have open, you can go to engineering.thezone.com to find out, or follow us on Twitter. And I cannot stress this enough, that we are hiring in Amsterdam as well as in London. And we've got a very nice office, about 10 minutes walk from here, so, why not? On a more personal note, I've been using AWS since about 2009, so it's coming to about 10 years now. And the last couple of years, I've worked on a few non-trivial serverless architectures, and I've been very active in terms of writing and sharing a lot of things I've learned. And some of that has also been put into a video course I'm putting together for Manning for almost, about 10 months now. And as Jason mentioned, since July this year, I've also been one of the AWS Serverless Heroes, which doesn't actually mean very much, except that they give me a ticket to go to reInvent this year, so that... Which is great, by the way. I'm not complaining or anything. Just that I'm going to be there in person to find out just how much of my 10 hours worth of content going to have to be redo because they change everything. I know a few people that produce video courses online. They all say the same thing. Every year they change the console, so you go back and redo about 3 hours worth of content. I'm not really looking forward to that after doing this for about 10 months already. So, getting sidetracked there. I've been using serverless for a while, and I've noticed a few challenges that the serverless paradigm has introduced. For starters, now we've lost access to the underlying operating system, so there's no way for us to install those agents and daemons. And for a very long time, we've been relying on, in fact, I think the whole monitoring industry has been relying on those agents to do the job outside of the critical path for the users, where we are really concerned about user-facing latency. And all these agents and daemons, they will collect your logs, they collect your metrics in the background, and then they ship them off to your monitoring system behind the scenes. And unfortunately, with Lambda and other similar platforms, you've lost that ability to do background processing outside of what the platform does for you. Another interesting thing that changed is that before, the concurrency of our application is managed by mostly our code. Our code will be handling, I don't know, X number of concurrent requests per second. So in terms of the systems that our monitoring platforms offers us, they're really concerned about minimizing CPU overhead or memory footprint so that they don't impact the number of concurrent requests that our application can handle. But with Lambda, another similar platforms, again, that the whole concurrency is now being lifted out of our code and into the platform. When HTTP request comes in, now it's going to hit only one instance of a running function that we have. So we don't, inside our code, we don't have to worry about managing concurrent requests, which is great because it really drastically helps us to simplify our code and open up some interesting opportunities for us in terms of how we build tools to make our system more observable as well. More on that later. But at the same time, we also lost some economy of scale, whereby before logs and metrics are collected and batched up at the instance level, or at least at the container level. Now, at best, what you could do is batch them up at a function invocation level, where every running instance of your function, you can imagine that being a container. So what that means is that in terms of the level of concurrency that we project onto the system that we use to monitor our application, is now we have far greater concurrency for those systems. And you might say, sure, that's an easy fix for that. You can just use a bigger batch, so then problem solved. Except it's not going to quite work that well. Because imagine when the new whole batch of traffic comes in, so in response, Lambda spawns a whole bunch of new containers to run your code. So every single time a new container is being spawned, the first invocation is what we call cold start, where Lambda has to bootstrap the runtime, bootstrap a container, and so on. And then if you just batch up all this information you want to collect in between invocations, and only batch them and send them occasionally, then what happens when that traffic goes away? Now, some of the containers are going to become idle because they're not serving requests anymore. And then after some amount of time, those idle containers are going to be garbage collected by the platform automatically, which again is a great thing they're doing for us. But it does mean that any data that you've batched up and have not sent will also be lost alongside with the container. So if you're using this strategy of batching and sending data, then there's a high chance of you losing them when the containers are garbage collected. And if you say, all right, fine, you're not happy, then I'm just going to send them at the end of every invocation. But that's also not great either. Because remember, there's no more background processing that you can do yourself, which means if you want to send, say, custom metrics or send metrics to some third-party monitoring system you have live as part of your function, then that means you're adding more time to your function's invocation time. And when you're building, say, APIs with API Gateway and Lambda, that means API Gateway itself is waiting for longer for your function to respond whilst it's busy sending data to the monitoring systems. And in the meantime, your user is having to wait longer for the response to come back and for your app to respond to him. So that essentially puts you in this awkward position, this catch-22 situation, whereby on the one hand, you are vulnerable to data loss if you try to batch them up and send them occasionally. On the other hand, if you try to send them eagerly at the end of every invocation, it also means that now you're adding user-facing latency, which is not great. Another trend that we notice with serverless is that more and more now people are adopting these event-driven architectures whereby you have, instead of everything being synchronous, you're now relying a lot on the background processing through event streams like Kinesis or through SNS or SQS and so on. And in general, we see a lot of function invocations being linked together via some form of event, so asynchronous invocations like the Kinesis, like SNS, like SQS, and so on. And of course, trying to trace those invocations through asynchronous event sources is a lot harder compared to something like the API Gateway and an API call. So those are some of the challenges that the serverless paradigm has introduced to how we monitor and how we make our systems more observable. But with that said, it's still quite possible for you to make your serverless application observable. And if anything, I would say that it's even easier to do so than before, where with containers, there's so many different tools for you to have to work with, to design, to configure, and so on. With serverless, certainly with AWS Lambda, you get a lot of them, the basic building blocks out of the box. So starting with logging, Anything that your function writes to send it out gets captured by the Lambda service asynchronously without adding to your function's invocation time, and then that gets shipped to CloudWatch logs, and you get some additional data around the timestamp as well as the unique request ID for that particular invocation, which is pretty good because now you don't have to do any sort of tinkering yourself to figure out how do you get your logs from your server or container to your log aggregation service. Now you get log collection out of the box. And inside CloudWatch logs, every function has got what is called a log group, whereby all the logs for that particular function is collected into what is called log streams. And you can basically have a one-to-one mapping between one of the rows you see here to an instance of a container that's running that particular function. Now, having that log collection done for you is all well and good, but there's actually a problem with CloudWatch logs in that you can't easily search anything. In fact, you can't search for the same phrase across multiple functions logs. You have to go and do that one by one to every single function, which is, of course, not how you want to work. So what you're going to find is that most people, they will go to CloudWatch logs console, select a log group, and say, you know what, I'm going to stream those logs to either a hosted version of the Elasticsearch service Amazon offers, or stream them to a Lambda function, and from there, I can just send my logs and to any log aggregation service that I want to work with. It could be, right now I'm using logs.io, but I've seen other people use Splunk and other services as well. So in terms of actually getting log aggregation set up, it's actually pretty straightforward. One thing to keep in mind with this setup is that CloudWatch logs itself is an asynchronous event source for Lambda. And when you're operating at scale, you have to keep in mind that there is this regional concurrency limit you can hit, and that limit applies to all the functions in the whole region. And any moment in time, you've got a bunch of functions that's all running and trying to do business critical stuff to deliver some value for your customers. And at the same time, all of those functions are writing to their logs. And in fact, every single invocation will write at least 3 lines of logs to CloudWatch logs automatically without you having to write anything yourself, which means CloudWatch logs in the background are going to be triggering your Lambda function to then ship them to your log aggregation service. And that can add to the number of concurrently executing instances of Lambda functions in your region. So that might push you a lot closer to the regional limit than you may realize. And when you do hit that limit, that means the Lambda is going to start to throttle Lambda function invocations randomly, and you have no control over which function gets throttled in that case. So you can end up in a situation whereby so much concurrent execution units are being spent on shipping logs that business-critical functions are getting throttled instead, which is not a good way to go. So what you could do is you can now either set a concurrency limit on that particular Lambda function that's shipping logs to your log aggregation service, or a better way to do that at scale is to, instead of having CloudWatch logs push the logs events to your Lambda function, have them push to a Kinesis stream first, and then subscribe a Lambda function to process events from the Kinesis stream. And the reason why you want to do that and why it's a good idea at scale is because between Kinesis and Lambda, you can control the level of concurrency with the number of shards in the stream. Every shard in the Kinesis stream has a dedicated instance of a Lambda function to process events from that particular shard. So in this case, if I want to say, I only want to have up to 10 instances of that Lambda function that's shipping logs, in that case, I can limit the stream to only 10 shards. Another thing to keep in mind when we're working with CloudWatch logs is that every time you create a new Lambda function, the system automatically creates a new log group for you. So what you don't want to do is to have a manual step whereby someone have to go into the AWS console and does click, and so then subscribe the new log group to your log shipping Lambda function. Fortunately, you can do that, or you can automate that by enabling CloudTrail so that you can start to create an event pattern in CloudWatch events against the create log group API call that Lambda makes on your behalf whenever a new function is being created. In this case, you can subscribe that event pattern against the Lambda function, whose job is to solely to subscribe the newly created log group with either your log shipping function directly or to a Kinesis stream. And you don't have to do this setup manually either. If you're using the serverless framework, you can actually just add a few lines of code to your serverless project, and that can create the event pattern and also hook it up to your Lambda function for you. Another thing to keep in mind is that with AWS, with CloudWatch logs, the default is to never expire your logs. And if you're shipping your logs to somewhere else already, and you're paying something like 3 cents per gigabyte per month for anything you have in CloudWatch logs, so there is a pretty significant long-term cost implication there, and it doesn't make sense for you to be double paying for the logs in 2 places anyway. So you can apply the same pattern and have another Lambda function whose only purpose is to update the retention policy to something more meaningful, like 7 days. And one of the most important and the easiest thing for you to do to make your system more observable is to just write structured logs. And it's something that many people forget when they move to serverless, because now they realize I don't need to use all these heavyweight loggers anymore. I can just write console.log, and everything gets collected and shipped to my log aggregation service. So all is great, but then at the same time, you forget about all these other practices, all these best practices that many of these loggers enforce. In fact, we've made the mistake of not writing structured logs in the past, and we've learned that lesson. And we know how to do it well within the microservices space, but for some reason, when we moved to Lambda, in serverless, we somehow forgot again. And even in the world of serverless, structured logging is still a very much essential part of making your system more observable. And even though I do find that many of the traditional loggers are too heavyweight for my use of within Lambda, whereby they support all these other things in terms of having different output locations to a file, to some other services, and the rolling files, and so on, all of that, I don't need any of that. What I need is a very basic thin layer of abstraction on top of console.log. So what we use internally is an internal library that I put together that's part of a bigger set of tools that integrates with how we handle correlation IDs, which I'll talk about soon as well. And the most important thing that it offers is structured logging and the ability to change the log level on the fly by modifying the environment variable. So what that means is that I can now change the log level for specific invocations. And because one downside of structured logging is that now you're writing a lot more data that have to go to CloudWatch logs. And within CloudWatch logs, you're paying something like 50 cents per gigabyte of data ingested, so 3 cents for every gigabyte of data that you archive. So on the face of it, it might not seem very much, but when you consider that with 50 cents, that's more expensive than 1 million invocations of Lambda for 128 meg function, then relatively speaking, it is quite expensive. And if you log everything in production, then what you normally find is that a lot of people are spending order of magnitude more on CloudWatch logs than they do on actually Lambda invocations themselves. So that's an important lesson that you don't want to learn the hard way. And I've known quite a few companies that have been caught out by this. When they looked at AWS bill at the end of the month, they realized, wait a minute, I'm spending $100 on Lambda, but then my CloudWatch logs bill is something like $2,000. What's going on there? With that said, we still need those debug logs in production, especially when things go wrong. And without them, what we often find, in the past, I found myself in a situation whereby something's gone wrong. I know I can find out what's wrong if I had the debug logs. So I ended up having to enable debug logs and redeploy my application, wait for the logs to come in so that I can find out and investigate what's going on. And then when I finish doing the investigation and fix the problem, I have to redeploy things and I have to disable debug logging again. So all of that just means that my mean time to resolution has been increased unnecessarily. And it gets worse as well. Within a microservice architecture built with Lambda, chances are the problem can exist in any number of different service layers. And to collect all the relevant debug logs, I have to do the same thing to enable debug logging in many Lambda functions across many different service boundaries. And that initial deployment to enable debug logging, then the subsequent deployment to disable them is just unnecessary if only we had some portion of debug logs always available in production. So a happy compromise between not having enough visibility but not having debug logs and paying too much for logging everything is to just sample a small percentage of invocations so that, say, 1% of your invocations will be logging at debug level and everything else will be logging as, say, warning or error, perhaps. And the way you can implement this very easily is through the use of middlewares, which is still possible and I would say recommended in the world of serverless. And if you're writing Node.js Lambda functions, then there's this middleware called MIDI you can use to write your own middlewares. And remember that my logger library, it lets me control log level on the fly by modifying the environment variable. So in the middleware, what I can do is, before invocation, I can change the log level for that invocation to debug. And then at the end of the invocation, after your code is finished, then I can change it back to what it was previously. And this is possible and only possible because we no longer have to worry about concurrency within our code, where the concurrency is now in the platform. So within one Lambda function, I know one invocation, within one invocation, I know I'm only dealing with one user request. So I don't have to worry about modifying global settings and global states, which then is going to impact other concurrently executing requests as well. And inside my middleware, this is it. It's as simple as that, whereby I check whether or not this particular invocation should be logging at debug level, and then if so, I enable debug logging. And at the end of the invocation, I switch it back. I roll back the setting. And another thing I like to do is when the invocation errors, I want to capture the invocation event itself as JSON alongside with the request ID, so that when I log. When I see those logs, I can see the invocation event that caused this function invocation to error, so that I can then replay those events locally by capturing the invocation JSON and then invoking the function locally against that particular invocation event. But then this sampling decision can't be just on individual functions, because again, within microservices, chances are many functions have to work together to actually make something happen, to provide the feature that you want to ship to your users. And if you only have sample logging decisions on individual functions, that you're going to find that for one user request, you're going to have some debug logs, but not others. And you can never have a full picture of everything that's happened. So you have to make the decision at the first function and then make sure that those decisions flows along to the rest of the call chain. And there's also other information that we want to flow through in the logs as well, including the initial request ID and user ID perhaps, and session ID. And I also like to record the user agent as well, because oftentimes I find that when I'm looking at the logs for some fourth layer of a function that's behind some Kinesis event or SNS message topic, I don't get a context of what user client was being used to create this event. So if I find that the event itself looks weird or looks wrong, what was someone trying to create that from the application? Did someone try to hit the edge-facing user sort of API with Postman or something? And since this has to be done all the time, you want to have a mechanism that makes it unintrusive for your developers to adopt these good practices, and it should be easy for them to do the right thing. And again, we can leverage the fact that we don't have to deal with concurrency in our code anymore, so that we can actually use something like global variable to store any correlation IDs that we want to use for this current invocation. And I also have a very simple tool, very simple library that just provides a very thin layer of abstraction so that you don't have to be aware of what global variable is being used and how we're storing those correlation IDs. And this library just gives you a very simple API to set a correlation ID if you want to, and also to collect anything that has been captured so far. And then we have a middleware that makes it easy for your function to automatically inspect the invocation event that comes in, and then extract any correlation IDs from the invocation event, in the case based on the convention that we have established in the team. So for HTTP requests to API gateway, we know that the correlation IDs are going to come in by the HTTP headers, so we can extract the correlation IDs from there. And in the case of an SNS message, we know that we put the correlation IDs into the message attributes, so that when we inspect the invocation event, we know for SNS messages, we can extract them from the message attributes, and then we can store those correlation IDs from the upstream into the library that stores them into a global variable. And then we can and then our middleware supports a whole bunch of different event sources, including API gateway, SNS, direct Lambda invocations, Kinesis streams, and step functions as well. And the logger knows where to look for those correlation IDs, so that whenever you log anything, those correlation IDs will always be included in your structure log. Cool, 2 minutes. And then finally, we also have HTTP and AWS DK client libraries that automatically grabs those correlation IDs and sends them forward, so that when your initial function initializes the correlation ID based on the request ID, and when you use the HTTP client to send it outwards to another request, to another API, they get included as the headers automatically. And then all your logs will automatically have the correlation IDs included. So there's a whole set of tools that we use internally that everything is integrated so that everything kind of just flows through without you having to do too much. So again, the idea is to minimize the amount of effort from a developer's part so that you can do the right thing easily. Running out of time here. So I'm just going to quickly walk through the monitoring side of things. You get a whole bunch of basic telemetry with your Lambda function, including invocation count and latency and so on. But remember, we don't have background processing anymore, so whenever you want to record custom metrics, you have to worry about how you do that because you don't want to add user-facing latency. And those user-facing latency can compound when you're talking about microservices, where one user action can involve several Lambda functions along the way. And Amazon actually found that every 100 milliseconds you add to your user-facing latency can actually impact sales by as much as 1%. So one of the workarounds available in this space is so that you can write your logs, so write your custom metrics as logs and have your log shipping function process them as metrics and send them to your log monitoring system instead. And that's how Sandra and a few other tools that are specifically designed for serverless are doing that as well. And in terms of this approach, you're adding delay to seeing metrics, and also you're adding additional cost and concurrency concern, but you are removing the latency overhead for your functions. And so for that, I would say when you're dealing with user-facing latency with APIs, try to consider this approach. But for everything else, where you're doing background processing, just send them straight to your monitoring system directly. And then you can create dashboards and so on. But you don't have to just use the CloudWatch either. Many providers, like Datadog, they also support ingesting monitor metrics from the AWS environment. So I'm going to skip ahead to the end because I've run out of time. Sorry. So I'm just going to leave you with a few important things I want to mention is that, by all means, write structured logs. Is this like the easiest thing and simplest thing and most important thing you can do to make your system more observable, and also instrument your code so that you can integrate them with your tracing solutions. And also try to invest on tooling so that you make it easy for your developers to do the right thing. And with that, thank you very much for listening, and I'm really sorry for running over, and I can't stress enough that we're hiring, so come talk to me. All right, thank you.